Hi, this is Ken Urban, and I'm going to make a video here to kind of discuss and demonstrate the idea of top-down design. Before we get started, just let me tell you what we've done and sort of where this sits in the grand scheme of things. We've done a whole bunch of C++ control structures like ifs and fors and looping and functions, and talked about reference parameters, and we're going to use code blocks because that's what we use in class. We haven't done some things like we haven't discussed arrays, classes, objects, multiple files in the class yet. So none of those things are going to be involved in this project, although perhaps they should be in the real world thing. So the project I'm going to use to discuss top-down design is kind of a silly game here called the horse race game. And the idea is that I'm going to have some number of horses, in this case 4, and I'm going to roll a dice. In this case, it would have to be a 4-sided dice. And whenever I roll that particular horse's number, I get to move it one place closer to the finish line. So for instance, if I roll a 1, right, I'd move horse 1. And if I rolled a 3, I'd move horse 3. If I rolled another 3, I'd move horse 3 again. If I rolled a 4, I'd move horse 4. And so on, until eventually someone's going to reach the finish line. So that's sort of the overview of the whole game. We're going to use a console, so it's not going to be as exciting as this. So there's our project. It's the horse race game. We're going to use the whole point of this is to illustrate this idea of top-down design. And there's sort of like one basic rule of top-down design, and that's to take the task you're working on. And to break it up into subtasks, and then take each of those tasks and break them up, right? And eventually, if you break it up into enough pieces, the pieces are going to be fairly easy to program. So rather than saying something like, I don't know, write a game, you're going to say do this, do this, do this, and then to do this, you have to do that. So you have to break everything up into smaller pieces, and we're going to go through and show what that means specifically in programming. I mean, you have to connect the pieces together. There's lots of other stuff that go on, but here's the main idea: is that you're going to take it, we're going to break it up, and put it in there. So I'm going to use code blocks here, and we're going to create a new project. We're just doing a console application in C++, and this is just going to be called something enlightening like horse race. Going to open my main, right? And I'm always going to check to make sure it runs and compiles. Okay, so it pops up there, everything is good. So we get rid of the hello world. Now, right, the idea, right, that we're going over is going to take a task, break it up into subtasks. So the whole task is write the horse race game. So let me sort of break it up into pieces. I guess the what's used for stories is like what, there's the beginning, there's the middle, and then there's the end. So right, we have an introduction, spelled correctly today. We're gonna let's say we're not gonna play the game. We're gonna run the race, and then we're gonna have the closing. Those are 3 pieces. I don't know, they could be broken up differently. I mean, it's kind of a up to each individual how to get it done. Now, another piece, so that I've broken it up, but another piece that I have to remember is that I always want my code to be running, right? And if I try to run it right now, right, we're going to see it's not running, right? Because introduction wasn't declared. So we're going to use another task, is we're going to stub out our functions. So to stub a function, right, I'm just going to go up, like here's the function introduction. I'm just going to make it void, call it introduction. I'm not going to send any parameters along. Right. And then I'm going to put it down here. Oops, cut and pasted the wrong thing. All right, I'm going to put it down here. So that's the minimum that's necessary for our function. The other piece I'm going to do is, while I'm in here, is the introduction is going to be any sort of notes that I want to remember or that would have to do with this particular function. Now I've just stubbed out one of them, and you can see, right, so I've stubbed them out, and I want to see if my code works. So I'm going to try to compile it, and I can see that, oh, it still says introduction was not declared. Oh yeah, we can see that I have some typos here that I ended up copying and can fix it. So all my mistakes are going to be like close by here, right? Just the stuff that I did. They're not going to be things I did, right? Oh, I hope my game is now back into running condition, or my code is now running. Right, so I've gone through, I've added some sort of pieces to here to do it. Right, so I've taken a bigger problem, broken it up into smaller problems. Now let's add in some of these things like the introduction. I guess we could just sort of do this ourselves, right? Welcome to Horse Race version 1.0 alpha. Right, and did a little bit of code. Let's test it. Let's see if it's working. Right, welcome to the horse race. Okay, doing good. I gotta declare victory on the introduction because I don't want to spend my time doing that. Let's talk about now the next one down the line is running the race. So, right, back to the same idea, right? We're gonna take this task of running the race and break it up into smaller pieces. So what can the smaller pieces be? Well, let's see. How about we initialize some stuff, and then we're going to initialize it, and then we're going to sort of run the race, and then we're going to finish the race. So how about while it's not over, so while not, let's say, finished, we'll call it. Right, so while we're not finished, what do? Well, we roll the dice and we move the horses. Right, so yeah, I broke it up into tasks, and I added some sort of structure to it here too, because I know what's going to happen, right? I got to set all my horses to 0. I got to do while it's not finished. I'm going to roll the dice. I'm going to move the horses and do that, right? Again, at this point, try to compile it, right? Not compiling. So I have, in this case, 4 functions now after it. I have initialize. Now, I've used finished inside a loop, so I know that's not a void. I know that's a Boolean. And right, move the horses. Right, and let's stub out those functions. For initialize, I put the horses in the starting gate. For finished, I'm going to return true if any horse has 1. Now, since this is not a void, I'm just going to put return false, right? Because it has to return something. Roll the dice is roll the dice, and move the horses is move the horses based on the dice roll. Okay, so we have that in there. Does it compile? Does it run? Let's see. Yes, it compiles and runs, and it just kind of sits there blinking at us, right? Because we have an infinite loop in here. Doesn't do anything. But we have pieces, right? So we've spent a lot of effort writing a whole bunch of stuff that really doesn't have, I mean, what, I have one control structure, the whole thing. It's a lot of, in some ways, wasted time. But I've added some structure to the overall program. Okay? Now I'm going to go down to initialize. So now I have to start sort of thinking about some details, right? I've broken it up enough, so I need to do some details. Well, one of the details, I guess, is like in the slide, we'll do 4 horses. So to put them at the starting gate, we're going to set them to 0. So it would be something like horse 1 equals 0, horse 2 equals 0, horse 3 equals 0, horse 4 equals 0. Right, that's kind of the idea, is that they're going to be set to 0, and then they're going to count as we roll the dice. Right, I'm going to compile it, see if it runs. Obviously it's not, because I didn't declare any of these. So how about I just do int, right? The obvious answer would be to do this. Right. Now it compiles and kind of gets stuck. Okay, so finished. Well, finished, right, is the next one on our list. Tells whether any horses is past the finish line. So I need to say what the finish line is. I'm gonna up here and do a const int called finish line is set equal to 10 for now, right? So that this is a global variable, they can all access it, and it's in capital. So to see if a horse is finished, right, if horse 1 is greater than or equal to, greater than the finish line, or horse 2 or horse 3 or horse 4. So if any of those horses is greater than the finish line, I'm going to return true, and then otherwise I'll return false. Now, again, I'm going to have the same issue when I try to compile it, is that horse 1 was not declared in this scope. And I can see pretty clearly that I want this horses to be the same as these horses. But variables are local, so somehow I need to get it from here to here, right? So to do that, I'm going to need to do it from here to here. So they're going to have to be sent into initialize and then come back, because they're going to change, right? If they change, they need to come back, and then they're going to have to be sent into finished. So I'm going to have to change my parameters. The parameters that we're going to need are going to be int references. Now let's see, I've called them horse already. And I missed the reference there. Just so I can read this a little better with my tiny little screen here, I'm going to format it a little differently just so I don't have to make anyone have to scroll sideways. Right, so there's what's going to go into initialize, and then for finished it's going to be similar, right, except they're not going to change because of the call. They're going to stay, right? They're not reference parameters, because checking whether a horse is finished doesn't change the value of the horse. So we kind of have an idea of what the parameters are going to be now. Let me go now start fixing things. So it compiles. We're going to need to change the stubs here, right, for initialize horse. And I'm kind of knowing these things, but we can also figure it out by trying to compile, right? Compiling is going to have us fix all these errors. Initialize doesn't have any variables. Right. Now, they haven't been declared here, so I need to declare them somewhere. I'm actually going to steal this line. Right. Declare them up here. Right. I'm going to pass them into initialize. I'm also going to pass them in to finished. And we'll do the compiling to see if everything's going. What do I have left here? Oh, it says again, horse was not declared in finished. Right? Finished has this prototype. So where's finished? Right. Compile again. Right. Well, nothing seems to be happening, but it compiles. That's right. That's our goal, is to have it compile. And as we add pieces in there, this is no longer stub. I'm going to take that out. And we have some of the pieces. So now we're not saying write a horse race. We're doing small things like, well, how can I tell if a horse is finished? Right? I'm taking that logic and moving it outside of it. Right? So now this is a little more concise. Couple of things we can see is that moving the horses, well, actually it's moving a single horse, right? We're going to need to send the horses in there. We're also going to need the dice roll. So how about we'll say the roll is equal to that, and we'll pass the roll along to a parameter, right? So we're going to have the dice roll return some number, and they're going to pass it along to move horses. Right, so that's how we're going to connect these two pieces up. Right, so this isn't a void, it's an integer, and this has 4 reference parameters because the value is going to change, so we need to make them reference parameters. And I'll grab this prototype for using down here. So now we've kind of change things. Roll dice. In this case, we're returning 1 to 4. So we'll do rand mod 4 plus 1. Right. I can compile it, and it says roll was not declared in this scope. Right. This was a change I just recently made, so I can add it in there. Right. Only fixing the first error. I see my indenting is a little off. Right, let's fix that. I cut and pasted something that I shouldn't have. Oh, let's see. Too many arguments. I have 5 arguments for moving the horses. Oh, up here I have 4, right? Because I have an int roll. Right, notice roll isn't a reference parameter because moving the horses doesn't change the roll, so we shouldn't make that a reference parameter. I have the roll here, initialize, finished, roll there. Try it again. Rand was not declared. Right, it was a change I just recently made, so I know how to fix it. Since I'm using rand and just put it in there, I might as well put that in here, and then up here in main, right, I know I need to set my time to 0. Might as well just do that now. Still nothing going on. Okay, I have my dice roll. My code nice and neat, and apparently it doesn't want to keep it neat. Let's see, move the horses, right? Well, we can see I now have broken the problem up into smaller thing, right? I'm given a roll, which horse to move, right? That's just a switch statement. I guess it could be done with an if too. Let's just play with the switch statement. It's an integer, so I use integers. Right, so if it's a 1, I'm going to move horse 1. 2, move horse 2. 3, I move horse 3. 4, I move horse 4. Right? Run it. It says welcome to the, and then it ended. Right? So it's ending. I can say, well, what the heck is going on? And the question I say, why isn't it printing anything? And then I can go here and look at this piece of logic and says, roll. I never printed the horses. So how about I do print horses? Right, and I need to print them in the beginning, and then I have to print them after they move, because I want to move them and then print the move. So, so my print horses, and I know I'm going to need all the horses in there. So, actually, I want to call this is printing all the horses. So I want to call it print horses. Looks a lot like that one. It's a void called print horses. And let's go right. The function. Well, that doesn't want to be over there. So to print the horses, I guess the first thing we can do is like that. Okay, fix my code. Right, so now I'm printing out some horses. I realize I printed the horses, but I'm not printing any of the dice roll. Perhaps this would be a good place to do it over here. When we roll the dice, let's show the results. Right, so rather than just returning the value, let's store it in roll. And return the roll. See if this is running. Now we can see that horse 3, 1 doesn't look very good. Maybe we want to kind of put each individual thing on the screen by itself, but I think I'm going to save that for another time. Right, so what we have now is a whole bunch of functions, right? Like what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8 or 9 functions, right? Each of those functions, right, even though this is a tiny little screen, all fits on the screen in one shot. Right? They all do, well, okay, I lied. They don't necessarily fit on the screen in one shot. This would if I format it a little differently, right? But it does one thing, like to move the horses, right? We're just checking the horses, moving each piece, right? If we want to change the way the horses print, what are we going to do? We're going to find the one called print horses, right? And kind of go from there. So that's the idea, right, of top-down design, right? You start with something, you break it up. You stub out those functions as you go along, right? Just start them in as empty and keep breaking it up. Because you're doing it this way, you'll always know what function to do next, rather than saying, oh, it's a big project, what do I do next? Well, you have pieces. You break it up, you have all those pieces. And then after you've broken up into the pieces and have some pieces, then you have to worry about the connections between those pieces and sending parameters to move information from one to another. Okay, and I'm going to end the video here for this piece. Thank you.